Good evening, everybody. You're all very welcome to this evening's Engineers Ireland event. I'm Tony Colahan, the current chair of the Electrical Division. And this evening, I'm joined by fellow committee member Charles Smith, who will be responsible for this evening's Q&A. The Electrical Division is delighted to welcome Eddie Nolan from Dynamic Electrical to provide us with a technical overview of the overview and insight into the capabilities of the mouse sticks fire suppression unit for electrical distribution boards. Before I introduce Eddie, I would like to take a moment to mention a few small housekeeping matters. So Eddie's talk will be followed by 10 minutes of Q&A. So can I just ask you to use the Q&A function rather than the chat function for any questions you may have for Eddie. So this evening's event will also be recorded, and all registered attendees will receive a link to the recording via the email address provided. So finally, the Engineers Ireland Electrical Division holds their online meetings on the third Monday of each month, and their committee members are a mixture of professionals from the low voltage, medium and high voltage sectors. So if any Engineers Ireland members are interested in joining the Electrical Division's committee, we'll be holding our AGM in May, and you're all very welcome to attend. So back to this evening's event. So it's a great pleasure to introduce this evening's speaker, Eddie Nolan. Eddie is a managing director of Dynamic Electrical. Previously, Eddie was employed by contracts manager with a leading Dublin electrical contractor for over 16 years. He initially served an electrical apprenticeship in the commercial and industrial sectors before progressing on to become an operations director with one of Ireland's major electrical contractors. Eddie has gained a vast amount of experience working on various healthcare and pharmaceutical and heritage projects, and he is now the proprietor of Dynamic Electrical, a company specialising in electrical distribution fire suppression systems. Some of their clients include the HSE and NHS, Pfizer, and to name but a few. So this evening, Eddie will highlight some of the common electrical faults found within electrical distribution systems and their frequency of occurrence. Faults such as loose connections, the crimping of conductors' insulation, the aging of conductors, and the selection of inferior electrical and electronic components. Eddie will focus on the potential of these faults to cause electrical fires and the damage they can cause to a business. Eddie will also discuss the significance of the electrical distribution resilience and the ability of the mouse sticks agent to extinguish electrical fires and maintain critical electrical resilience after the breakout of fire. So with that, I would like to now hand you over to Eddie for his discussion.
Thanks very much, Anthony. Appreciate the introduction. So good evening, everyone. So today I'm excited to discuss the importance of fire protection in electrical infrastructure and how mouse fire protection systems can significantly enhance the fire safety in our electrical distribution networks. So as Anthony mentioned, I've worked in the electrical industry for over 20 years. I'm a time-served electrician and worked my way up to being a director of a large electrical contracting company. So in this role, I would have been responsible for over 100 electricians working on many different projects in healthcare, commercial, retail, and heritage sections. So I've delivered many different projects across all sectors and collaborated with many professionals, and I think I've gained vast and valuable experience in this time. But so in 2020, I decided I set up my own company, Dynamic Electrical. The idea being set up as a small contractor to use that experience that I've gained and to start delivering quality work in our industry myself. But I was then given an opportunity then to get involved in this new fire suppression product for distribution boards, which was something that intrigued me because I had experiences in the past with fires and distribution boards. So it was of great interest to me. So today we'll discuss the issues of fires in distribution boards, how to mitigate these risks. It's something that I've come across a few times in my career, but I'd never really come across any systems that prevent such an occurrence. So as part of the presentation, I'll discuss some of my own personal experiences dealing with the fallout of electrical fires and the effects it had on business continuity. So we'll discuss some of the statistics that are available to us and highlight the prevalence of these instances. So, as we all know, our electrical infrastructure has become more critical than ever, um, with electrical systems touching everything, everybody, every device in every industry. Down to the cars we drive now, it's gone electrical. So it's become more critical than ever to maintain and take care of our electrical systems. With our worlds becoming more electrified, electrical load is only ever added. It's never taken away. So so with our systems under increasing pressure, the ability to carry out routine maintenance or upgrades, it always requires shutdowns, which have become next to impossible in large businesses like hospitals, especially trying to upgrade the infrastructure is very difficult. So I think we have a risk of inadequate due diligence practices being applied when we're adding these additional loads onto existing distribution boards. So for instance, like we're adding car chargers across the whole country at the moment onto our distribution networks. And while I'm sure most contractors and designers will ensure that the capacity is available, um, many don't, and it results in overloading of inadequate existing infrastructure, which leads to fires, obviously, So, look, to give an example of overload, like our company, we recently hired a commercial kitchen RDS, um, but the client replaced all of his gas ovens with electric ovens. Um, Now these are big, heavy electric ovens. I think they were 63 amps a phase. I think there was four or five of them. So it had a massive knock-on effect of the with the existing infrastructure and the electrical load. And we ended up having to get a huge cable. I think we had to run parallel cables back. Um, we to modify the existing main board. Like we had to get all the way back to the main board. And the knock-on effect was huge to the client. Which is fine. We explained what happened, but I think the point being, I don't think the client had considered the knock-on effect of just moving everything to electrical. So it's something that we need to consider. So given that more of our systems are relying on electrical infrastructure, the sudden loss of this network can result in catastrophic consequences. So as our networks become larger, the time it would take for a disaster recovery significantly increases, which, depending on the nature of your business, could have serious knock-on effects. Like, so if everything is becoming more electrified, you have an issue with a distribution board. You're trying to get that distribution board back on. You have more and more systems that now have to be either rewired or reconnected, recommissioned. All of that is time getting it back up and running. So I think we should have more focus on protection of our electrical infrastructure, given how important it is to our everyday lives. So obviously there can be many reasons why a fire may occur. I mean, we spoke about additional load, which is obviously a big one. Um, there's also loose connections, faulty equipment, as well as external influences, leaks, damage. I'm sure we've all seen a board where water ingress has got in for whatever reason, or that and damage to components. Can cause a short circuit, which you can end up in a situation where that short circuit can result in a fire. Um, like we carry out routine maintenance like thermal image and periodic inspections, which is obviously ideal, but there's still only a snapshot of the electrical infrastructure on a given day or given time. So it's still not there's no guarantee that you're going to stop a fire just because you've seen that you've done a periodic inspection or a thermal image survey. There's so many reasons why a fire can occur that, okay, it's best practice to carry out such maintenance, but it won't guarantee the prevention of a fire event. Um, so I've obviously been doing a lot of research into this now that I've got more involved in this industry, and unfortunately Ireland isn't great at recording source of ignition statistics, and even Dublin isn't recorded at all. So if you go onto the CRO website, you'll see Dublin is actually scratched out, and they don't highlight it at all. Now, I've spoken to several Dublin fire brigade officers and during my research, and what they tell me is that if they have a major fire event, it's actually the Garda that are responsible for the investigation. So it ends up falling between stools. That's what I'm told. But I've been anecdotally I've spoke to these guys, and they tell me that it's a significant issue. Fires and distribution boards. They're called out many times um for these issues and smoke coming out of the board, and so it's certainly a prevalent issue from their side of things. So I looked here because we're over in the UK as well. So I pulled some stats from the UK Gov website, and I took some statistics of source of ignition for England. This is England alone. Now, so if you think, given that our standards and regulations, and electrical equipment are very much aligned with the UK, I think it'd be safe to assume that the statistics for the UK should also align with Ireland. And if you see from the graph there in the slide, like, so 15% of primary fires were caused by electrical distribution. I was fascinated, but that was a shocking number to me. Um, so it highlights how prevalent this issue is, and even excuse me, if you look at the footnote, like the source of ignition that accounted for the largest proportion of other building fires was electrical distribution. What they're referring to in other building fires is non-residential, so non-dwelling. Excuse me. So when you take out the smoking and the cooking appliance, electrical distribution is the largest. So that's all your businesses, all of the business and commercial, industrial plants. That's the largest proportion of fires in the UK. So I mean, I think it's safe to correlate the two across to Ireland. It's got to bear the same. It's got to have a similar set of statistics if they were taken. Um, so I suppose I'm going to talk about a couple of my own real life experiences in dealing with the fallout of electrical fires, and I suppose I should just point out before I start that there's no correlation between me having to deal with the fallout of these fires and my competence. I didn't cause these fires. I just had to react to them. So, um, I I'm just conscious that I'm saying I've been involved in these fires, and people might think it's something to do with my installations. These were not installations that we had carried out, but they were clients that we had to react to. So I'll just make that important distinction before I start. But the first story I'm going to talk about, this was a large retail store. So we got a call, the worst call an electrical contractor can get, to say that there's smoke billowing out of the switch room, and to get lads down here quick. But so what had happened there, you can see in some of the images, there was a short circuit in, I think it was a 160 amp breaker offloader. Um, we're not sure how the short circuit happened, but whether it was component failure or some sort of ingress into the board. But what happened was the short circuit fault current um wasn't enough to trip the ACB, the main ACB. So obviously there was poor discrimination, which obviously is another scenario. I mean, maybe if discrimination was correct, it may have just tripped and cut off the power, but it didn't. It actually bypassed the main ACB and tripped out the MV, which in turn brought in the generator, which is possibly wrong as well. That probably shouldn't have happened either. But it brought in the Jenny, um, which energized back onto the panel. And because the fall current wasn't big enough to trip the ACB and the Jenny, it just kept banging at the fault until it created a big fire. Um, Now, luckily, the staff were fairly well trained, and they were able to isolate the Jenny, so they had to emergency stop the generator, and they fought the fire with the correct extinguisher and was able to contain the fire to just that cubicle. Um, which was lucky, obviously, because I mean it was also lucky that the panel was in the kind of plant room away from the retail store itself. So if that had been in a different part of the store and near textiles or anything, like you'd have been dealing with a complete different scenario altogether. But we arrived to site. The store had been evacuated and closed, so they're without any power at this stage. And you're facing with this scenario where the fire had started in a small cubicle, but unfortunately, because it had raged so much, it spread to the right hand side, and that's the buzz bar section. So that's the main buzz bars that were feeding the rest of the panel. So the whole panel was now destroyed. So we were now dealing with a scenario where we had to try and divert any of the critical cables that we could to other distribution boards and joint boxes, and we had to split the panel as much as we could as well, and to get a panel manufacturer out. It was all hands to the pump, loads of that, all working all through the night to try and get as much critical parts of the store as we could back on, for so that they could maybe open the next day. And now we ended up getting something done by diverting cables where we could, and we got most of the things back on. But I mean, they lost all the refrigeration, and the fallout was the cost. I don't even know what the final cost was, but it was huge. As well as the just the damage, reputation damage, and everything else for the store having to close and the power down. It was a huge fallout, which could have been prevented if the fire hadn't spread to the next buzz bar section. So really, what ended up causing so much damage and why it was so hard to get the store back on was because it spread across and melted the buzz bars, which fed the rest of the panel. And that was what made it more difficult, because you couldn't use any part of the panel to get the store back up and running. Um, so that was one fairly heavy one. But there was another incident. This is in a healthcare environment, hospital. So um, we would have, and again, there's no correlation here. People are wondering how I'm involved in so many fires. It would have just been a consequence of me being responsible for so many projects and so many clients. So it's a volume game is why I've had these. I haven't had many, but I've had a couple of major ones. But this was another major one in a hospital in. I'm not going to obviously mention any names or anything in my stories, but these would be well-known places. So this was an event, another call, smoke billowing out of a riser onto a ward, and we got the call. By the time we'd got to site, the staff had extinguished the fire. So they'd again use the correct fire extinguisher and extinguish the fire, but there was there was a couple of people in theatre at the time, so we couldn't actually isolate that distribution board. So all we could do was monitor. So the fire brigade were on site as well, and they they were happy that the fire was contained and it wasn't reigniting. But all, there was all arcing and flashing going on in that distribution board, and we couldn't actually isolate it. We had to wait until the teenagers were finished. Some guy was getting heart surgery, and so we had to wait. And this was lucky, like it was lucky that some part of the board was still operating somehow. Um, but um, so we had to wait until he got out of theatre. Now, while this is all going on, we're only dealing with the fallout of the electrical end of this and getting the power back on. Like there's a huge disaster recovery mission going on in terms of evacuating that ward and getting patients to a nearby hospital. Like, so there's huge fallout that I wasn't anywhere near responsible for, but you can imagine the knock-on effects that go on in these scenarios when you're dealing with critical infrastructure. Um, what had happened in this scenario was the fire had spread, but it spread up in, if you can see the image on the right hand side, into the header trunking, and the fire spread throughout the trunking and up through the riser. Now, luckily the fireproofing was quite good, and it was in a protected riser, so it was in a fireproof riser, and they had put pillows in the trunking, so the fire didn't actually spread up to the next floor. Because if that had been the case, it could have actually spread up through all the floors, and it could have been dealing with the evacuation of an actual hospital. So in some sense, the fireproofing was great. That worked and kept, but it didn't help us out a lot, because you had a scenario where all the cables were all melted together going up through the header trunking and up the vertical trunking. And when we finally did get a chance to isolate the distribution board, trying to figure out what circuits were what and which neutrals were with what, it was an absolute disaster. We ended up having to rewire, critical circuits and get as much as we could onto different boards, and, get what you can up and running. And then over the course of a couple of weeks, then try and get a new board in and redivert, and like, so just a massive fallout. Again, that would have been at least not prevented. You're still going to have an event, but it was the spread of the fire into the trunking that melted all of the circuits that really made it difficult getting the everything back up and running. So if you had had it just within the board, you could have had a situation where you still could see what circuits were what, and you just have a better chance of recovering the situation in a quicker amount of time, and less damage. So it was what had actually happened in that scenario, it was only when the guys had rewired everything, they realized that there was a lift wired off the panel, and there was a main supply to the lift, and there was also a lighting supply to the lift, probably to do with car lights or the shaft lights or something. But somewhere in the lift there had been a mix up, or the main neutral wasn't connected or broken in some way, and it was using the 2.5 lighting neutral to power the lift, and something came loose, and it went up like a tinderbox. That's what happened. So again, which goes back to the many different reasons. I mean, that's quite unique. No one's ever going to think that's going to cause a fire. But that's the scenario that happened there, which nearly shut down a hospital. And like that, so there's so many reasons. Um, so like the reasons are plenty, but the fallout is huge. So it's something that um again, it just comes back to it comes back to protecting our vital infrastructure. And so that happened in my career as a contracts manager and director with a large company. But more recently, while we as Dynamic Electrical, we got a call from a large pharmaceutical company, and this only a couple of months ago, just after Christmas. Um, we got a call from a large pharmaceutical. They'd seen just our videos on LinkedIn, and asked could we come out and visit their facility and run through how our fire suppression system works. And it turned out they just dealt with a fire incident themselves that caused the evacuation of the plant. Um, and and what happened was a fire broke out in a UPS changeover switch, which was in a room with an FM200 system. Um, so this was like a and pharmaceutical, in fairness, they're great at maintaining, and they've the best of infrastructure. So they actually had a UPS. This was a UPS switch room, so they had banks of batteries, UPS changeover with an FM200 system that to suppress the whole room. But the FM200 system didn't work. Um, Now these are not a client of ours, so I don't know why it didn't work. But it did get me thinking. Um, we have situations where we have an FM 200 system that's designed to suppress a large room, and we design it on the volume of the room. But do we ever consider that within these rooms we can have large electrical distribution boards that are basically a room within a room? So you could have a scenario where a fire could smolder in a large enclosure. Smoke could could double knock the fire suppression system. Um, but the fire and release the suppressant gas, but the suppressant gas may not be able to actually get to the fire that's smoldering within the enclosure. Um, so you can have a scenario where you think you've suppressed the fire, and then you ventilate the room, bringing fresh oxygen to a smoldering fire. Now, I don't know what happened in this scenario. This is a fairly uh, new discovery for me. They got in touch with us, and they asked us to come out and have a look at the facility. And at the moment, they didn't want to tell me too much, so they just said, look, it just didn't work, and we're looking at your product. So, we actually done a tour of the facility. We done a demonstration on site of our products, but in that scenario, certainly fire suppression within a distribution board would have been a massive benefit, because I know the cost of shutting down pharmaceutical plants is quite hefty. And when we did the demonstration for the guys, you could tell you could tell in their face that they would have liked to have our products in there. As I said, I'm not sure what happened with the FM 200s, but I see a situation where um we could supplement, like, it's not like you still need your fire suppression system. Like, there was a battery bank and everything, so you still need to flood that room. But it's certainly worth considering having some fire protection within the enclosure as well. So it's a belt and braces thing. Yeah, I'm not saying it's instead of, like, obviously you still need your fire suppression systems and everything about them. They're fantastic systems. They work great, and if you had a battery bank fire or something like that, of course you want the whole room flooded. But there may be consideration for these small enclosures in the scheme of the room, but large enough in terms of electrical, that can be protected within the room. So it's it's just something that it's a potential solution that could at least have minimized the fallout from the fire event. So it's you're not going to stop the fire event, but you're trying to at least minimize the damage done and the fallout from it. So which leads me on to our solution. And I'm going to play a video here, and hopefully you can just watch the video, and then I'll talk a little bit more about the solution then after it's played. So so as you can so as you seen in the video there, that was the Mouse 6 Pro um activating and extinguishing the fire. So it's basically it's a simple device, the Mouse 6 Pro is placed in the top of the cabinet, be it a 3M sticker. I'm not sure if you've seen that at the start of the video. You can see my arm just very simply just sticking it into the top of the panel. And what you're seeing then is the heat sensing cable ignites and strikes across a solid chemical pack that's inside the Mouse 6 Pro, resulting in a chemical reaction which turns the solid potassium non-toxic solid chemical into a gas form that floods the cabinet and extinguishes the fire. So it's a very clever invention and a very clever innovation. It leaves no residue, so it doesn't harm any of the electrical components. It's non-toxic and environmentally friendly. It's non-pressurized, so and there's no electrical connection, so you don't have a pressurized unit inside your electrical cabinet. It's obviously small and it's very easy to install and activates at 170 degrees. And I suppose the biggest selling point for us on this is that it can be installed without any shutdown. Um, so you don't need to power down the distribution to install it because it's such an easy install. It's no different than when you're doing a thermal image survey and you have to remove all of the covers. Okay, it has to be performed by obviously well-trained personnel, but and it's obviously easier if you can just switch off the power and safer and everything else. But if it needs be, if you're dealing with critical infrastructure that can't be shut down, you can install this fire protection as an added safety measure and without any disruption to your business. Um, as I said, this opportunity was brought to me by a Swedish company called Mouse Safety. They're in operation since 2013, and they've lots of different products using that particular gas to extinguish fires. But obviously the one that struck me as most innovative was their patented mouse sticks for protection for small, medium, or large enclosures. It's having worked in the electrical industry and having experienced some of my experience, like you've just seen there. Obviously, I was fascinated by the cleverness and the simplicity of the design. Um, you'll see a couple of the yeah. So at the moment, um, the Mouse Sticks Pro it's a supplementary product. So it's not designed to replace any of your existing regulated or required protection systems. It's just a supplementary product. So it's something that if you have a proactive client that wants to add a belt and braces approach to their electrical infrastructure, this can be added in. So we achieved C certification in late 2022. Um, so it is a relatively new technology. Now we're actively looking to achieve new standards of certification where we can, but sometimes the current methods of testing are not applicable to our new technology. So it's not always easy to just try to adhere to any of the current fire suppression standards or anything because it's a different form of technology and a different method of distributing the gas. So it's not like a compressed bottle distributing the gas. It's a unique way of reacting. So we're finding it difficult to get new standards to be approved to current standards. But we, we'll keep continuing. As I said, it's a new innovation, so it's going to be something that's gonna be around. So the product start with the Mouse Sticks Pro. This is the small unit has a coverage of 0.1 of a cubic meter, and this unit would be ideal for your consumer type unit, your domestic consumer unit board, the small boards and houses. And where I come in then is the advanced version. So a lot just it's just the nature of where I've always worked is commercial industrial. So most of our clients are commercial and industrial. I just never really worked on residential. Although it is that product is perfect for a domestic board. But when you get to the advanced version, this is the one I recommend more for commercial settings. So when you get to the advanced version, that's point 0.2 of a cubic meter, but it can be chain linked together. So when you're dealing with larger panels, you can chain link the advanced version together. So it's more suitable for like MCC panels and larger distribution boards and where you have like a Form 4 board, you might have smaller cubicles, but then a large terminal section. So that's where these come in. And then it comes into the five, which is zero point 0.5 of a cubic meter, and again can be chain linked. So it just gives that greater flexibility when you're designing for a commercial panel, as to you can tailor a solution that gives you the coverage you need in commercial panels. And then you go into 10, which is 1 cubic meter, which is significant space. Again, you'd be into really large panels there with that one, and again can be chain linked together as well. Um, so to recap on the principle of operation, so it activates at 170 degrees, releases a non-toxic aerosol in the form of potassium compound that will remain within the cabinet. So when you're designing, you just obviously over engineer to make sure there's more flooding of the agent within the cubicle, which allows for any leakage and that. But once that's activated and the potassium has flooded the panel, it will stop any reignition without damaging any of the components. So it's okay to just smother that fire and be within that cubicle. Um, it's not going to damage the components, but it stops any reignition. Um, so these are just a couple of our sample installations that we've carried out in some of the major hospitals in Ireland and the UK. And so, for instance, like we're about 3/4 of the way installing these in Beaumont at the moment. And as we're going through, so we we've managed to install it. So we're probably about, I'd say 3/4 of the way through Beaumont. We're there a good while now. And we haven't had to switch off one breaker. So we've installed them throughout the hospital without having to switch off the power once, which is obviously a huge benefit. I mean, that was the major selling point for Beaumont. They obviously they can't switch off the power. And again, you see them now installed in these cubicles. And so if you look back at, say, and I might just flick back, so you see where they're installed now in them cubicles. And if I go into, I'm going to roll back to the slide, the retail scenario that I had. Because if you look now, so if you had one of the mouse sticks in that cubicle in the top right, and you had your fire in the 160 amp chamber, but the message would have flooded that cabinet, flooded that chamber, and okay, you still have your fault, right? But at least the fire wouldn't spread into the right hand side of the enclosure, and that was the main buzz bars that was feeding the rest of the panel. So that was the real problem, because that meant the whole panel was gone. So if we had to stop the spread, the fallout was the problem. So the spread of the fire is what caused most of the grief. And actually, I'm not sure I mentioned it when I was talking that time, but the fire spread above the panel, and there was a couple of data cables that were running above the top of the panel, and one of them was a fiber, and didn't it melt? So we melted there was a fiber melted at the top, and that actually caused more grief. Like I remember dealing with the fallout of this electrical problem and trying to work out where we're going to get these loads from and what panels we can get, and we can divert to, and what we can give them, and what can be got back on. And it was only when we started getting systems back up and running that we realized that this fiber was gone as well, and had to get a guy out to splice it and joint the fiber. Like, the fallout from the spread of the fire is the real issue. Like if that had been just contained to that 160 amp enclosure, okay, you isolate that one, you move on, and you can look at getting it replaced or tidied up. But the fact that it's spread across both out and across into that buzz bar section is what caused most of the grief. And not to mention that was a lucky scenario. So it was lucky that it wasn't in a store with any textiles around it, or you know, because it was in a kind of an external room type room. It didn't spread or catch fire anywhere else. So it's just an example where that could have really um made a big difference in that scenario. And I suppose similarly with the hospital, the spread of fire is what made the return to power and return to normal services difficult. If the fire hadn't spread into the header trunking and rose up the trunking, we wouldn't have lost all of the circuits, and you end up with a full rewire rather than being able to maybe just get back on quicker. So we're not going to, our products won't stop these incidents happening, but stopping the spread is a huge factor. So so yeah, so these are some of the sample installations. And again, some of our some of our clients. So we've been quite lucky with some of the clients. So Dynamic Electrical have the exclusive distribution rights for the UK and Ireland. So we actually we've actually got some great traction amongst some really big clients, which it's actually to my own surprise that these clients have been so proactive in their approach to fire safety, and the adoption of the new technology. I mean, I suppose maybe that's why they're market leaders. You know, I've been overwhelmed by the success so far, and and although obviously we hope our clients never have to rely on our product, it certainly bolsters their fire protection of their critical infrastructure. So a lot of what we do for our potential clients is presentations like this, but we've a test rig that you may have seen some videos on LinkedIn. We've a test rig that we can bring out to the premises of a potential client, and just demonstrate the product extinguishing a small controlled fire in a car park. It's a great way to explain how the product can offer that additional fire safety protection. You can actually see. So, I mean, you can send on all of the data sheets in the world, but there's nothing like actually seeing a product work. And there's not too many fire suppression systems that you can go out and show a client it working. But it's because it's so small and it's unique that way that you're able to just come out showing working. And it's a massive benefit to us anyway as a company. That's probably more of a business thing and a sales thing, but it's just great to be able to show clients it working. So I mean, it shows that you're standing over your product as well. You're willing to go out, show them it working in a live demonstration. Um, so we've done that lots of times. Like in that pharmaceutical scenario that we were at there just after Christmas. So like we walked the building, we went through how we could install it in their existing plant, and but we finished out by carrying out a demonstration in the car park, in an enclosure not too different to the one that had gone on fire. So I mean that client was very impressed, and he's told us that they're definitely going in. So that'll be another huge pharmaceutical added to the clients list shortly, I think, as well. And there is certainly a demand for this out there. And although my own evidence is anecdotal, the UK stats are clear, and I think it's something that as designers of future buildings and any upgrades to existing, I think the fact that our electrical infrastructure is such an important part of our lives, um, and the fact that in reality, as it stands, there's no such thing as fire suppression. Like nobody has it's never been done. And now we know there's a product out there that can protect our electrical enclosures. I think it's certainly something that I'm trying to build awareness that there's a product now out there that can help with what is a fairly prevalent issue and one that causes major disruption. And not to mention potential loss of life if a fire does get out of hand. So I mean, I've spoke mostly about business continuity here, but I mean, there's also, real life consequences if a fire does get out of control. So so that's kind of so. I suppose in conclusion, I'm not sure how we are for time, but in conclusion, the mouse fire protection system, in my opinion, represent a major shift in electrical infrastructure safety, offering proactive solutions to mitigate fire risks. As industry professionals, I think it's incumbent on us to prioritize safety and embrace innovative technologies that can safeguard these assets and lives. So together, I think we should embark on a journey towards enhanced fire protection and resilience, hopefully with mouse. So um, thank you. And I can probably go on to maybe the
Th
questions if
th
that's okay, Anthony.
thanks very much, Eddie. Appreciate that. Yeah, it's certainly a concern that the stats relating to electrical fires, particularly in the Dublin area, aren't readily available to ourselves, And obviously, this is something that needs addressing, but it's also good that
Absolutely.
yeah, you can draw on your own anecdotal evidence over the years, to raise our awareness of, the risks, surrounding electrical fires and the dangers, and how they can be exacerbated with the electrifying of our energy mix. You mentioned, car chargers and solar PVs. Yeah. So look,
Exactly.
thanks a million.